Okay, short introduction to roots and powers with exploring inverse operations. Just the idea, and you're not going to see this out of me that often, but the inverse operation is to add. We add to both sides to maintain equality. These guys cancel out or add to 0. We get x equals 13. For the rest of them, check the answer sheet if you want. Basically in class we'll go through these fairly quickly. All right, we're going to subtract 5 from both sides. That's the inverse operation. As long as you're doing it to both sides, you maintain equality. And this is a equals 7. Divide both sides by 2. M equals 5. Multiply both sides by 3. Actually 3 over 1. I like to do it that way because it shows, especially when there's a fraction here, in which case let's write that as 5 over 1. And the 3's cancel. When you cancel, you write a 1 in there. Don't just cross them off and think there's nothing left. And then c is equal to 15. B squared, b is equal to, okay, now this is something we're going to hammer on quite a bit, not necessarily so much right now. When you take the square root of both sides, it's really plus or minus, because we're saying we're going to square a number, and that number could be 5, or it could be negative 5, right? Negative 5 quantity squared, that would look like this, is equal to positive 25. Well, really, let's expand that a bit. It's negative 5 times negative 5, which is positive 25. Here we're going to do the inverse sine operation on something. You have to do it on something. And the inverse sine of 1/2. And the inverse sine of the sine, it's kind of like square rooting a square, right? You're just undoing it. It gives you theta, and this is 30, and it's degrees. Maybe I am going to do a bit more than I wanted, but we'll still try and keep this short. For the answers to these inverse operations, just look for the answer sheet. Okay, so now I'm going to cut that. And then the same thing here. And this introduction to roots and powers is really just getting very familiar with the numbers. Okay, so be very familiar with these numbers, the perfect squares, because you're going to need them all through high school math and into any subsequent math you do, just knowing that 81 is a square. And especially as we get up into the larger numbers, 144, 169, 196, 225, 256, which is 16 squared. And know your perfect cubes, up to 1,000. So you should be basically filling these in. And, I want you to know that 343 is a cube. Even if you don't remember that it's 7 cubed, know that 512 is a cube. You can always do the cube root operation on them using your calculator. Knowing your powers of 2 is important, right? Again, you may not know which power of 2, but know that 512 is a power of 2. It's also a cube of 8. And know that there's a couple of powers of 3, 81 and 243. Be familiar with all these numbers. You don't have to memorize them, but sit down and at least look at this. And then know your square roots and your cube roots. Now, the difference is when we use the radical sign, we're talking about only the positive or principal square root, right? And we'll get into that. And where am I? So then these 1, 2, 3, 4. So these are only the positive value, right? We're not saying this that b squared is 36, so b is plus or minus 6. We're saying the square root of 36. So there's that distinction to keep in mind. Okay, I'm just going to fill the rest of this in. So cube roots. So no cubes, no cube roots. Know that the fourth root of 16, the fifth root of 32, the sixth root of 64, the fourth root of 81. Okay, we're going to end this one here, and then Radical Dude follows that right up, and into roots and powers we go.